Hello! In this video I will show you how to use the script TreeDistMatrix.run. This script requires three inputs: a dataset, an alignment, a reference tree, for example a species tree, and a set of individual gene trees. Then the script displays different tree distances in the form of a distance matrix or a heat maps. The measures included in the script are the number of SPR moves, the SPR difference, the normalized Robinson falls distance, and the distortion coefficient. The links to access to the articles describing the measures included in this script can be found in the description of this video. For this example, I will use the GUI version of TNT. However, as this script has only 3 arguments and is very simple to run, the instructions to run it are the same for both the GUI version and the console version of TNT. In this video, we will use the same dataset used in the tutorial of the script GUI from this paper. The dataset has 310 defined blocks, summing up almost 240,000 characters. The number of terminals is 46. So first, in the GUI, we need to load the dataset. For that, we go to the menu File, Open Input File, and choose the data file. Then we need to load the reference tree in the same way that we did for the data file. And finally, we need to load the gene trees in the same way that we did for the data file and the tree file. Remember, as for the script GUI.run, we must load into TNT the dataset, the reference tree, and the gene trees in that specific order. That is because the first tree in memory will always be the reference tree for the script. Now I will show you the help of the script. For this I need to type run TreeDistMatrix.run help. Here is the entire information of the script. As I mentioned, the script has only 3 arguments, so I will copy the usage and the arguments that I want to use. For this example, I will use the distortion coefficient. For this, I need to type DC. I will produce the graphical output. However, as this is the default, I don't have to specify this argument. If your dataset contains the names of the blocks, for example, those datasets produced by the script compilegenes.run, see the video on that script, you can choose to produce the output file with the names of the blocks. In that case, we need to type names yes. However, as the dataset used in this example does not contain the block names, we will use names no. This option is the default, so we don't have to specify this argument. Now I just need to press enter. And that's all. The script produces 2 output files. First, I will show you the SVG graphic with the color-coded distance matrix. Here you can see the distance matrix. The first tree is the reference tree, while the rest of the trees correspond to the gene trees. The genes trees could be incomplete in relation with the reference tree. It means without some of the taxa sampled for the reference tree. For that reason, we include the number of terminals of each tree into parentheses. Finally, you can observe that the boxes in the heat map are greener as the trees are more similar. On the contrary, red color means more different trees. In addition, the distance matrix is saved also in a CSV file that you can open with Excel, R, or other softwares. The trees with fewer taxa than the reference tree are indicated with an asterisk in the CSV file. This is the end of this tutorial. Thank you and see you in the next tutorials.